today I'm joined by Thomas Howe. Thomas is the Regional Construction Director at Prime Data Centres. Has been working in the data centre space for a vast number of years, and he's going to tell us where he believes the data centre market is going over the coming years. So, welcome, Thomas.
Oh, thanks, Sean. Thanks for having me. Appreciate it. Feel free to
Perfect.
call me Tommy if you want to, but don't have
Yeah,
to. So,
yeah. I think we discussed your new nickname, Tommy, now, isn't it? So,
yeah, yeah, yeah. It feels pretty good
yeah.
sometimes. So, yeah.
So, Tommy, do you want to give us a little bit of a kind of an overview about your experience within the data center space? Yeah,
Yeah, I think it's interesting. I started the working in data centers in 2008, coming from as a mechanical engineer. So it was really interesting because I started in the Department of Energy and working on high performance computing. So at the time, those were pretty high density racks. And so I was working as a mechanical engineer doing mostly municipal water projects.
yeah,
And then they had this new data center project over at Argonne National Laboratory, and it was pretty small comparatively today. It was like 5 megawatt system with a 5 megawatt redundancy with it. And they wanted somebody that understood pumps and water, and being the fact that I was doing these like municipal water treatment plants and whatnot, I had that kind of background. And the reason why they wanted it is because they were implementing liquid cooling, water cooling data center, which like fast forward today, that's what our industry is going in heavy with right now. So
yeah,
it's really cool. It was really neat. So that was my first cut. And so that was back in 2008. It was the first data centers. I didn't know, what it was looking like, what data centers were. But the really cool experience there is like I got to like really have a lot of interactions with the scientists that are using those computers, and they were doing
yeah,
really cool stuff like modeling like the galaxy, studying dark matter, doing projects with like Boeing and their like combustion of the engines. It was fascinating, right? So they needed like
yeah,
this really high intense computational computer, and they needed a data center to support that. So that was kind of the first cut I got my experience with
yeah,
data centers. Um, and then like I mean 4 or 5 years later, I jumped into like the capital world, and totally different, right? So then I went from like leading technology, leading edge, slow. Like that project was I was I started in that project in the middle of it. It didn't get deployed in 2000 until 2011. So that was like a 7 8 year time frame between start of the project to the finish of the project. So government, very project, but leading
yeah,
technology, right? Very cool stuff. Jumping in the capital world, it's fast. So like the first project I got after that was for a provider there, and it was like a 9 megawatt data hall that we had turned over in 3 months, right? All air cooling,
good
so
deal.
completely
Yeah,
different, right?
yeah. From one
And
end of the spectrum to the other.
yeah, yeah. And vast, like the government section of the high performance computing is like small, like really close knit. Everybody knows everybody. And you jump into the kind of the capital world, and like it's so big. You got so many players out there, either like they're providing the equipment thereof, they're providing the racks, they're providing the general contractors. It just became opened my eyes up to like the whole industry itself. And so
Yeah,
and that was like in 2012 when I went to the Capital World. And then so here we are today, and then now turning over data centers every three months, depending on the size of it. I've worked on like large data centers, campuses with like high performance computing, as well as like hyperscalers and the like thereof. And then like today, like I noted earlier, is like it's interesting because the density going up, like I would say like we're like 25% of all data centers are going into the liquid cooling, and that number is going to go up, right? So
yeah,
it's cool. I got to, lean in on some of the experience I got, maybe 10, 12 years ago. So
yeah,
currently I'm working with Prime, and we're fast pace. There's not enough demand to feed the appetite that our social culture drives. Because in my opinion, like AI, like all our devices, our mobile devices, our virtual reality, like it's exploding. And so the demand is like skyrocketing now. So it's a very, very busy time in the industry. It's a fun time. Yeah.
Yeah, no, for sure, for sure. And you obviously touched on there. I think 18 years ago was your first kind of foray into the space, and you were on liquid cooling. How have you seen the industry evolve over that time?
It's mostly the technology is somewhat the same, right? So when we did the liquid cooling back in the day, like what we learned there is one, density is going up, so the structural component is getting more critical. So the weight load, like how are you supporting it? So that's kind of like tampering some of the growth like upwards, and so you're starting to see some data center campuses not being able to kind of go as high. Like if it's a two-story building, three-story building, that structural becomes like very critical. The other thing too about the liquid cooling aspect of it all is that the quality is like really concerning. So we had issues with our water quality, and it's got to be because you have these like tiny little orifices going inside the computer itself that are pacifying the cooling that's needed. The quality is like like super important, very
Yeah,
critical to get right. And then you have this mesh of between like the outside of the computer versus what the inside of the computer, and that water chemistry it needs to be like synchronized. And so that hasn't changed. The issue is that what changes is that you have different now technologies have different requirements, different internal components. And so the requirements are the same as you have to take a look at it, you got to match it up. But some of those kind of like solutions are a little bit different.
yeah,
So like now you have providers now that they'll provide like end-row CDUs, right? So cooling distribution units. So instead of going straight to the chip, the facility wire is going to the CDU at the end, and that's providing like the liquid cooling in like a different like refrigerant type. They might be using some sort of glycol mix or whatnot. So it's it's opened it up. It's opened that technology to like different solutions. Um, but it's still kind of still in the same ballpark, and you still need air cooling, like you still that hasn't changed either. You just need less of it. So now it's kind of like a little bit of the complexity of the balance of the ratio. Is it 35% air and 65% liquid, or is it 50% air? Because no matter what, you still have like bulk power enclosures or bulk power modules within the computer
yeah.
itself that can't get that water. It's like you're just never going to get away from that.
And
So
what would you, in your experience, obviously touching on that, what would you say the optimum kind of level is on the cooling side? Or
The
is,
optimal you want to get, I think you want to get like 80-20.
right,
And right now the industry's not there. Like for the most part, I think we're like 60-40.
yeah,
And it'll probably kind of get up, and optimal is like 80. You can do it 80%. The IBM Blue Gene Q computer that we did back in 2008, that was like a 90-10.
right,
And then when you have that, what's really cool about that, because like there's so much energy in it, like you can start doing things like waste heat recovery, which is really important. We can probably talk about that, about like how we involve an environment. Um, and then your PUEs becomes really critical. And so like the 80-20%, 90-10%, that's where optimal is. But the industry's not there. We're right now we're
yeah.
like 60-40, right?
Yeah, yeah, it makes sense. And obviously one of the biggest challenges in the industry, that's why I talked on water, but obviously you talk about energy and obviously continues to be a challenge. Like, what do you see as some of the key issues in the grid space?
Well, the biggest challenge is that like the layperson doesn't know because for example, like I mean 5 years ago I was building like 10 megawatt buildings, maybe like 30 megawatt campuses, and now the buildings are 72 megawatts. That's not like a double, that's like exponential growth in the energy
Yeah,
demand. The energy's out there, the infrastructure is a little bit lacking. But the reality is that when we're talking about our power consumption and data centers getting bigger and bigger and bigger, it's the lay people, they don't understand it. Like they kind of still think that we're having like energy conservation measures. I mean, they're thinking about LED light bulbs or energy efficient cars, but the reality is that as a consumer, as like the population, we are using a lot of energy.
yeah,
And at some point we have to kind of figure out of the efficiency thereof. And so with the infrastructure outside the data center.
yeah,
So that's the energy's out there. It's just more about the distribution to kind of get it to the data center itself. Um,
yeah. I
you
think
know?
I think like you said, the infrastructure doesn't obviously when the industry has scaled so quickly over especially over the last 4 to 5 years, and we'll probably touch on AI later, but obviously huge facilities. We've gone from 10 megawatts, 20 to, to
Yeah.
gigawatts now. You're talking of the infrastructure hasn't probably gone 50x at the same time the energy has. So, there's all automatic there, not the right infrastructure in my opinion anyway,
Yeah.
from
And
the
then like
outside.
so and everywhere you go, there's like usually just one power source, one provider that's providing it. And I have a lot of empathy for them. Like they've given some major hurdles to overcome. And so they're just
Yeah.
getting bounded. And so how do they do it? Like the challenge of them is like they they'll say yes to everybody. Like, yeah, we can provide that. Yes, they'll put in some of these letters of intent and make all these promises. But then what happens also from their end is that maybe they allocate 10 megawatts to this user, 50 megawatts to this user, 350 megawatts to this other user, but they don't use it, right? So like they're seeing in the meter that it's not, maybe it's like not 300, but they're using 250. And so all the while this is being built and built and built, and at some point there's crosses that happen. It says, wait a second, we need to kind of like reevaluate our allocation, our distribution. It's
Yeah.
with one, if you have one utility provider, that's a lot to put on one person's shoulders. So it's
Yeah.
I can completely empathize with the utility providers out there. It's a big challenge for them.
Yeah. And do you think that obviously do you think that's the biggest obviously challenge within that space?
Yeah, I mean, so I think the reciprocal side of it is the environmental challenge. So with that, the impact we can put on for like that's plus to the environmental, like we can do like carbon concrete. There's these small things that we can do when we're building all these data centers as fast as we can that are sustainable, that help the environment. But it's like a drop in the bucket when it's talking compared to like how much energy use we're using. And so the bigger thing is that, when we have the redundancy, take a look at. So what I mean by that is like most of our data centers require generators as a backup source and redundance.
Yeah.
And in order to operate those generators, we have to run those generators an hour a month just to make sure that they're in the best condition in case the power does get pulled.
Yeah.
That's our generators now are 3 megawatts, 5 megawatts. So we run a 3 megawatt generator for 1 hour just for maintenance purpose, not even using the energy, it's just for
Yeah. Yeah.
maintenance. And
Yeah.
like, how much is a megawatt? How many homes does that provide? That's like 600
Yeah.
homes.
Yeah.
It's,
I know. I know.
you know?
Yeah.
So we're running a generator for an hour that can power 1,800 homes, and so just for maintenance. So there has to be like a change in that. That's a challenge, right? And then
Yeah.
you're going to start getting pushback from the our neighbors, our municipal partners there, because there's environmental impact. So there's a balance that goes back and forth, and so I don't think the providers, I don't think the hyperscalers are going to change their requirements. They want the redundancy, right? What has to happen is that pushback has to come back from the municipalities, the people that aren't in data centers, like, well, we want you to use less energy. Well, one way to do that is to take the generators out, maybe put a redundant source of utility power in. So there has to be kind of like a reasoning for them to push back. And it's hard, right? It's hard because there's so many layers of
Yeah, it's not just one. It's not just like a one person speaking to the next. There's so many independent people, regulations in between, isn't there? And I think with especially the hyperscalers and these massive facilities these days, like if the power goes out, they're talking of millions of pounds an
yeah,
hour. Tens of millions a day in some cases that they're missing out on. So they, when you invest in $1 billion or more into a facility,
yeah.
you don't want that facility to go out.
Ever.
So
Yeah.
yeah, yeah,
It's hard. It's
yeah,
a very hard discussion. I think there's a good example in Maryland. Maryland as a state that hasn't been always open up to like Maryland, US, hasn't
yeah,
been open to data centers previously. And they have this kind of incentive to start opening it up because it's really good for communities. It really does help with your tax revenue. You could take those and put it to like a municipality could put that to good sources.
yeah,
But in that, so Maryland had this, data center development happening, and there was a lot of money that was being sent in there. But the EPA came in and said, hey, like you have to rethink the generator's usage. And then to what you're saying, exactly, it's like, well, the data center, the hyperscale providers, like, you know what? If you can't have the generators there, we don't want to build there. So they move out.
Yeah, we'll
They
take
run
it
away.
elsewhere. Yeah.
Right. So you have on both sides, you have really good arguments. You have Maryland says we want to protect our environment, we want to protect our noise, we want to protect all these things. And then the commercial end's like, well, like we have billions of dollars at stake. We have investors, right? So
Yeah, yeah,
this is trade-off the balance that needs to happen.
yeah,
And so it's a lot of discussions, a lot of politics in that to manage the environmental side, the energy side, and the financial side, you know? So
yeah.
it's fascinating, you know. So
And I
you know,
think that sometimes, obviously, speaking to people daily in the industry, that's the one thing everyone talks about holding the industry back is the power side, isn't it? And
yeah.
yeah, I think it's a massive challenge, but it's not an easy fix. It's not an easy solution because, like you said, there's so many different parties involved in actually making sure it's feasible for everybody, right?
Yeah, yeah. There's a lot of voices out there,
Yeah,
and how do you get all these voices into room, you know, in a short period of time, and then allow people to collaborate. It's and they all have
yeah.
different backgrounds too, and they all have different wants. So
Yeah, I think that's the challenge. Anything in life, isn't it? When you've got different people with different perspective and different wants, like that, the hyperscaler wants it, the power to there all the time, the generator there all the time. But you've also got then the people in the community that obviously have their own vendetta against it,
yeah,
etc. So, it's trying to come up with a solution that kind of is acceptable. It might not be the best solution for all parties, but acceptable because, yeah, like you said, there's so much money involved and so much for the economy in states that if they take
yeah.
it away, it obviously can affect you as an individual in that state in other ways, can't it?
Yeah, and then that's just getting started. Like, because then
Yeah,
after, because once you get started, then it's 2 years to build it, right? So we, or, you know, to build it and fill it, you know, bring in the users and start using it. So there's so much like work that goes up in front to kind of like face these challenges, the energy challenge, the environmental challenge. And then I think I don't want to go. I want to go back to a little about the energy sector too. It's like I think one thing positive thing I think about data centers is the AI. It's almost the same conversation. It's the double-edged sword, right? AI is every day creeping more and more into our lives, and it's making things simpler. And I firmly believe that when we have these challenges about distribution with electrical, like AI is going to help us solve that, right? It
yeah,
organizes, it coordinates, it finds the path of least resistance that allows us to kind of develop our infrastructure that we need. But at the same time, that's the same thing that's like demands more power. The computational power to drive AI
yeah.
is up. So I feel like, it's this race of like AI creating the solution that solves some of these kind of convoluted and very complex problems that we have and getting these things started. But at the same time, it's like it's the cause of the problem too, you know?
Yeah, I think I think that's the problem in because, like you're saying, it's like a catch-22. AI can solve some of them challenges, but we don't have enough kind of power at the moment and energy to actually make it better. And so
Yeah.
it's like trying to weigh up everything to make sure we get the best solution in some ways.
Yeah. So
Yeah,
I could see that in like when I work with utility providers too, you can tell that they're getting a little bit more advanced, they're getting more complicated. And so, it's just a matter of time before they kind of put that software in place or put whatever program they have in place that kind of like spits out those solutions. So,
yeah,
I'm a fan of, I'm a fan of AI. Like, I think it helps a lot. You solve a lot of things,
yeah.
makes things more efficient. So, um, but I do recognize the fact that it's taken over a little bit.
Yeah, I think, I think there's always, whenever there's new, it's playing a massive impact, isn't it? And I think a lot of stuff is, when you see layoffs happening in the market, people are blaming AI when it's probably not AI in some
Yeah.
respects, but it's an easy cop out, isn't it, etc.
Yeah.
Like, as a user of AI daily, we need to use it to kind of facilitate and make our jobs more efficient and stuff like that. But that then increases other things, doesn't it, that you're able to do so. But I think a lot of people are wary of AI because they see, well, in 5 years' time, it's like this today. What's it going to be like in 5 years' time? How's that
Yeah.
going to affect my job, etc. So it's people are always daunted by technology advancements, aren't they? And it's obviously
Yeah.
scaling very quickly.
Take how like AI might impact us. Like it's because when we go into a new data center, our data centers are not they're somewhat idiosyncratic between like one provider to the next provider, but they're very similar. Like 3 megawatt blocks, 4 megawatt blocks, generators, UPS. They're very similar. Providers do it slightly different. So imagine if I'm a developer, if I'm a user, and I go up to a provider, I say, I want to use you. I want you to build me a data center. That's where AI is probably going to step in, right? So because we've done it so many times, it's soon you'll be able to kind of tell AI to make you a design. Can you spit
Yeah.
out? Can you spit out? Right now, they can't do, it's too much computation for them to do, to put all those pieces into place. So, but you can kind of see those engineers, the designers of record, they're going to start implementing that. They're going to hit the button. Like it's going to be something where you're going to be on an a la carte. You're going to be like, well, do you want UPS 10 minutes or do you want UPS 15 minutes? Okay. Pick your poison what you want, push the button here and there, and then AI is gonna maybe take a day to kind of spit that out. I think that's kind of
Yeah.
like what I see of where, AI is going to replace a little bit of our what our designers and engineers do. But now the designer and engineer has to kind of like check that because obviously it's not perfect like that. So they have to kind
Yeah.
of do
Yeah.
do
Yeah.
does this meet the design intent,
Yeah.
So
I think like obviously like anything, AI's obviously got its benefits and its also flaws. But like you said, if a designer then spits all out, they've then got to validate it because they can't pass that design on to somebody that's incorrect,
yeah.
right?
Yeah, and if you mess up, you can't be like, "Whoa,
Yeah, it's the
AI did."
AI, blame AI. Yeah.
Yeah, it's
That
not me,
doesn't
it's
fly anyway,
Siri.
at least at the
Yeah,
moment.
yeah, for
Yeah.
sure.
Yeah. So, and do you think the industry can adapt to the increasing kind of grid demand then?
I think eventually it's got a plateau. I don't think it's just it's on an exponential growth. I think that manpower is grotesquely underserved. And it's what you see now. I'd say like maybe 4 years ago, we talked a lot about the trades. Like there's not enough electricians, and there still is not enough electricians.
Yeah.
And I tell you what, what's been pretty good is that the pay raise has been very well for electricians. So I think
Yeah.
there's more people coming to trades. My kids, I'm constantly telling them, it's like you should definitely look at the trades. Like it's a good time to get in. You can retire early. It's a lot of work. It's hard work and stuff like that. There is a shortage of there. And then I think I'm primarily based in Chicago. I love our trades. I feel like Chicago is the best. The Midwest in general just has the best trades. We have the highest quality work. And I seen that from looking at projects in other places on the West Coast or the Southwest. And I'm like, no, this like trust me, like we can teach the Midwest can teach a lot of trades of how to do things in high quality standards. The
Yeah.
problem is what you see now though is like it's a lot of the administrative side, which is shocking. Like I can't hire people that have the data center experience to manage it, to do the administrative work, like to run the meetings, to make the decisions. That's where I feel like the shortage is right now. Whereas before I think it was more in the trades and in there. Now it seems to be like, the administrative and the project management side. We don't have enough.
Yeah.
And so
Yeah.
so right now we're getting a ton of people coming from like pharma, big pharma's coming in. I'm always in oil and gas. So like the people are leaving, some of the management people, some of the engineers are leaving some of those industries to come over to the data center because it's attracting a lot. So, but we're
Yeah.
short. We're short still. And that's going to bottle us down a little bit about our growth and development. The other thing too
Yeah.
is the other thing is like equipment. Like, it's so hard to kind of get quality equipment as fast as we need it. The life cycle of the data center starts with like when we sign with the provider, and that's like that's $1 billion, or I'm not, $1 billion is probably too much, but it's a lot of money when we sign, and we have to hit that date, or there's liquidated damages.
Yeah.
It's like $10,000 a day and just adds up, right? So then what it becomes is that we're hypercritical on delivery of equipment. We can't have it too early. We can never have it late. And the quality has to be there. It has to arrive
Yeah.
on site, like ready to go. And that's what we're seeing either too, because the industry is expanding so much, and so a lot of us are building the the hyperscalers get the best equipment and the best vendors, but there's still so much like appetite out there that we have to shop around. So we'll get the second queue, right? So if there's a premier chiller manufacturer, and we'll have a ticket in for them, and we'll expect something like 6 months to be delivered. A hyperscale can sometimes come in and be like, "Hey, I'm the big guy. I'm gonna take the little guy's equipment," and then that
Yours is
manufacturer,
pushed back 3 months, or
yeah,
yeah,
and it'll impact us. And I don't
yeah,
blame that manufacturer. Like they want that business. That business is really good business, so it pushes us
yeah,
out. So that we might have to go source from somebody else, and then we might get a lesser quality on delivery. We think it's supposed to meet this drawing or these
yeah,
requirements, but it shows up. We're like, oh, that's why that manufacturer is number one, right?
yeah.
So you're starting to see a lot of newcomers that are providing all the equipment necessary to build it. And that's like a definitely challenge to kind of maintain like a standard of all this equipment that we need to kind of build them.
Yeah, well, I think if you're building a facility, right, there's so many different providers needed. It's not just like you're not dealing with one manufacturer. You could deal with hundreds, can't you, and stuff at any
Yeah,
one time. So it's like making sure that, like you said, quality and speed, like what's more important, like they're both equally as important. But like you said, there's a massive, you've got to hit that deadline,
yeah,
so if you don't hit it, so that's when you have to probably accept the quality has to diminish to get it over the line, don't you?
yeah.
Yeah,
That's a
which is obvious.
common That's a very common, question and discussion that happens in everybody. Like every company out there is having that same discussion. It's like, what can we live with to get speed to market or to meet our deadline or support our customer, Um, so it's a constant challenge. So the way you're seeing, and then let's go back to the management staff. So one of the solutions to that is to get to the manufacturer, put eyes on it, have conversations with that, but the managed staff is lacking because we don't have enough people like can it just do that, like to have those kind of conversations and meet those manufacturers. And so it's
Yeah,
it's manpower, but it's like,
from a project management perspective,
yeah,
basically.
yeah,
Yeah, we see that all the time. Like there's just not enough project managers. Construction on the electrical side, there's just not enough people.
yeah,
And I think that it becomes a problem because everybody kind of wants data center experience. So it's like, well, if the data center market is growing exponentially, there isn't going to be enough. So somebody, again, there's obviously a lot of crossover with other industries, but most people want somebody, especially from a staffing perspective, that they've done it somewhere else.
yeah,
Because if you don't really want to take a gamble, because like that if they haven't done it in a data center market, you may
they
argue
don't
that
know.
yeah, they don't know. So everyone doesn't want to take a risk. They want the solution that ultimately isn't going to get their boss saying, "Why did you do that?" Which obviously is a challenge, right? Because everyone then's fighting over the same people. Do you know
Yeah,
what I mean? Which is tough.
yeah, the experience is like really well valued now because it's very instinctive. Like there's on like $150 million construction project, you might have $150 million OCI equipment. And some of that equipment is pretty straightforward. It's not complicated.
Yeah,
But but if somebody's new to it, they don't know the difference between like that complicated piece of equipment that you have to kind of pay extra attention to versus the one that is like normally plug and play, right?
yeah,
And so you kind of need that kind of like inherent experience on site to kind of direct the people, like you need to pay attention to this, like get the guy here, get the tech here, open
yeah,
it up, look at the guts, and like why? It's like well, we have 3 months time. I was like, trust me, you gotta open up right now,
yeah, yeah,
and
yeah,
start tinkering with it because it takes 3 months to tinker with this stuff, But whereas
yeah,
another piece of equipment may be the same cost, same size, but it's so simple. So you're not gonna have,
yeah.
sometimes you don't have that kind of like inherent understanding of where are the biggest risks on a project.
Yeah, and I think obviously, like anything, there are obviously, like you touched on, there are some industries that are similar, but everything has its nuances, don't they? So, like I said, when people are staffing projects, they usually kind of want sure bets, because they want to know, like you've seen that, you're talking about that equipment there, you know what to do with that equipment.
Yeah,
Everyone's busy. You don't need to ask that question to somebody else, etc.,
yeah,
because everyone's got their own job. And like I said, there then isn't enough people because everyone wants that experience, don't they?
Yeah. So you look at, I
Yeah.
think what's interesting like is like the general contractors, I think is a very interesting like place because what general contractors will do, and they're doing very well. I feel like the one like entity that's doing very well, like in this whole thing, well, everybody's doing very well, but the general contractors are doing very well, and they do a good job. But what they do is they bring in a lot of young like talent in, and that's the issue is where the provider or the owner really needs to kind of understand of like the general contractor staffing, right? Because they have bodies, they're out there, making sure they're doing the work, but they're like every time I work with a general contractor they're always like educating like the young guys and it just
Yeah.
it always drives me crazy. I'm always like I paid good money to have like the best here and it's like
Yeah.
but I have empathy for them too because they have their growing business and they have to train their guys too, so it's like it's a
Yeah.
it's a
And it's
balance.
it's tough, isn't it? Because if they don't, then the staffing shortage is only going to get worse. Do you know what I
Yeah,
mean? If they're not, so like you said, but sometimes when you're paying the money,
yeah,
you don't want somebody to be learning on the job.
learn exactly,
um,
exactly.
yeah,
Yeah,
I mean, yeah, a different story. It's like my wife gave birth a couple of months ago, and there was somebody,
at the
doing a
hospital.
procedure on her, but she was a trainee. She got it wrong, and it's like you don't want that kind of situation in happening, do you?
Yeah,
In
you're like,
in
this is
any
your
walk
first
of
time
life.
in surgery.
Yeah, yeah, yeah. So you can imagine, obviously, something went wrong and everyone's panicking,
Yeah,
etc. And but that's the same in anything. Obviously, when you're having something done for you, you don't want somebody like making that mistake ultimately. You want somebody that's
yeah,
been there, done it, but then you have empathy because I'm like, well, yeah, they did make a mistake, and it wasn't ideal, but ultimately if they didn't make that, then like they wouldn't be learning, would they? So it's
exactly.
but you'd rather
Yeah,
it not be on you, would you? You'd rather be on like for you, you'd rather be on someone else's data center project that they've worked on previously, and
yeah.
they're coming to yours, not making the same mistake, because then you're getting the neck, aren't you? Probably from your boss, etc.
Yeah. Yeah, you can see
Yeah,
how like I don't know, like socially complicated it could be, right? So, and we're all part. And
yeah,
what I love about the data center industry right now is like it definitely feels like a lot of us are partners. Like I don't feel like even like my competitors. I feel like we're all like kind of like trying to help each other out. I feel like that. I don't know why, but I feel like on my project in general, we've kind of grown into this like this talk of let's be good partners. Let's try to
yeah,
work together.
yeah.
So,
I
but I
think
don't.
everyone's
Yeah.
everyone's obviously got some skin in the game. Everyone's got the common goal to get it delivered. Everyone wants to make money while they're doing it, etc. So, and I think if you're clashing, it just makes everybody's life harder, doesn't it? It's already stressful as it is because you're working on such tight deadlines,
Yeah.
etc. So you kind of want to get on with them people. It's like anything, you don't want it to be transactional. You want it to be more of a partnership, like you said.
Yeah. But I think, I
Yeah.
mean, overall, like the original question, like of like, you know, the trend I see, I think my gut says it has to plateau. I don't think it's a bubble. Like I've heard people say like a bubble like that. I don't see it being, it's so substantial. Like I don't see it being a bubble, I think, but like we talked about earlier, there's got to be some pushback on the environmental side, the municipality side, and I think that might kind of plateau the industry a little bit. So the growth would, maybe not as extensive, right? But there's certain like our social appetite is so big that I just don't know when, to forecast that, you know.
Yeah, yeah,
But I can't wrap my head around of it being, continue at this pace. That's
yeah.
unheard of. It's like the Industrial Revolution, but even the Industrial Revolution plateaued, right? Every time we get into this like eras of our society, there's always a point where it takes off and then start to kind of like still go up, but just not as fast.
Yeah, yeah, yeah. And we obviously touched on equipment and kind of manpower, etc. Like, how do you think that's going to play out over the next like few years? How do you think that's going to play out over the next 3 to 5 years? Do you think there's still going to be
I,
shortages in areas, or do you feel
yeah,
like the
I
market will
feel like
catch up?
well, I think 3 to 5 years is going to be very much like this year. I think it's going to be like the same for the next. Like, I don't think too much is going to change, but behind the scenes, what's going to happen, I believe, is like the technology is going to evolve. We talked earlier about the DOE, how 10, 15 years ago they were doing liquid cooling, and 15 years ago now we're all doing liquid cooling,
Yeah,
right? And that's the intent of the Department of Energy, right? They're doing things on the taxpayer dollars to kind of create, you know, inventions and technology advancements. Lithium ion batteries came from Argonne National Laboratory. Now UPS is usually all lithium ion batteries, and that was not a correlation between data centers. That's just how it happened. So behind the scenes, you start seeing different architecture on computing, and so that's where I think people really start paying attention to quantum computing. I think quantum computing is maybe like 7, 8 years. You're going to start seeing data centers starting to build for a quantum computer, and I think that will be a different game changer. I think that the idea there is to use less electrical consumption. There's a Moore's law, like, has this graph where, the petaflops, or the floating operating points per second, goes up exponentially, and so does the power, because ultimately it's just getting denser and denser and denser into that microchip. Quantum computing changes everything, right? I'm not pretending to be like as smart to understand like how it all works
Yeah.
out, but I do know that the ultimate goal is to kind of reduce the power consumption, have the same amount of computational power, do the same amount of like flops, but with less electricity. And we start to see that kind of evolve. Maybe that's more like the 10-year time frame. We're gonna
Yeah.
start to see maybe like the power consumption come down. You'll see like a little tightening on the equipment, and then that will probably be like the next evolution of our data center market. At least in my opinion, that's kind of where I tend to like pay attention to.
Yeah, yeah. When you talked about obviously quantum computing, obviously that's like a another thing on top of, like, it is a version of AI, but it's another, it's in a completely different stratosphere, isn't it? Like,
Yeah.
why do you believe like power? You're talking about Moore's law there. Why do you think that would then have an impact on the power and actually reduce that?
Well, quantum computing, I'm not that great at it, but the quantum
Yeah,
computing kind of uses like more like all the electrons in phase, as opposed to like the circumference of like the circuit. So I forget the term they use, but essentially like it's evolutionary in the fact that they can have like the phases and at the silicon chip at the very low level there. And so you're not gonna have the necessary like the increased density that you need to create all the copper, or not the copper, all the like conductors inside it to create the logic gates. I mean, it's mostly about
yeah,
logic. What is computation? Like, it's just like computers are just ones and zeros. Like, all it is, like, and then so they're just ones and zeros stacked up, in infinite across it to create the computation that you need. And so all those ones and zeros, for the most part, is electricity going through it. It stops there. It can go this way, 0, 1, 0, 1, 0, 1, and it's all. And then the cooling you need is is to dissipate the resistivity of that electrons going through those boards, right? So you
yeah,
introduce quantum computing, you're taking away that resistance, like your cooling comes down, right? Because it's zero. It's like the resistance is zero, so you're not like generating heat, so you don't need to remove that heat.
yeah,
And then you start reusing those electrons. And so is it 10 years away? Is it 15 years away? I don't know, but it's like, to me, that's the game changer point. When that kind of hits, I feel like data centers are going to look a lot different. And then, like, I think you mentioned AI. Yeah, AI is going to help with that. AI is going to like advance that computing architecture.
yeah. Yeah. And
It's
do you
fascinating.
think, yeah, I know, we're not, it's just, there's so many people talking about them being in orbit and space, etc., isn't there? And it's just
Yeah.
like, yeah, which is just a whole another level,
Did
isn't
you
it?
see
Because
that? Did you see the data center in space like conversation? I was
I
like, that's
know,
crazy.
well, people generally think, and there's like companies that think in 5 years they'll be, orbit in space, and they're talking about you look at Elon Musk and his kind of predictions on the
Yeah.
markets. It's fascinating, isn't it? To be fair, I mean, yeah, there's some very smart people making some bold predictions about where the market's heading, and obviously, and I think obviously if the space thing is coming because the power costs are rising, the energy costs are rising, and obviously there's obviously factors within space that they believe it'll reduce the cost massively, and I think that's
Yeah.
in any walk of life, that's what everyone's trying to do. Like, efficiency is basically making things cheaper. Like, ultimately, that's what they're trying
Ultimate.
to do. If they
Yeah.
can if
It's
they can find
synonymous.
that solution, it's just how that would work. I just can't really imagine it in my head. but yeah, I think a lot of people are trying to tackle that issue, aren't they?
Yeah, absolutely. Yeah.
Yeah,
No, it's pretty fascinating.
yeah,
Um, yeah, and other than that, I don't know. I mean, I don't know. Well, I mean, I'm along for the ride, This is next 3 5 years, like, it's gonna be intense. It's gonna be people are gonna make a lot of money and but it's fast paced. It's a really good industry to be in.
yeah. And do you think that's where in your head, we're gonna see the biggest change over the next 5 to 10 years in kind of because we talk about 3 to 5 years. You don't think, obviously, the market is evolving. It'll be more megawatts facilities, thing, etc. But do you think in the 5 to 10 years, that's when you're gonna see more of the impacts on things like quantum computing having an effect on the industry?
I think no, I think in 3 5 years is like I said, we're gonna keep growing at this growth. I think in 5 to 10, we're gonna get pushback from municipalities. Energy is gonna really kind of ramp up. We're gonna kind of like get we're gonna meet some challenges that's gonna slow us down. And I think when we get to the 10-year mark, we're gonna start seeing the early stages of quantum computing, like maybe the first, and I bet it's in the government sector, right? So, and then add that to the government sector, they're going to start, tinkering around with that, come up with like something they can deploy, a prototype, and that will then be copied, by the capital industry. And so by the time that kind of becomes full scale, that would probably be another like 5 to 10 years. So I think really before we get into like this really reduction of power consumption and efficiencies, it's going to be like 15 to 20 years. 3 to 5
Yeah,
years, I think it's the same. I think we're gonna hit the challenge of like our social appetite, our environment concerns, our energy restrictions. That's gonna hit us like in about 5 years probably.
yeah,
We'll push through it. It's gonna bottleneck it, right? And then once you get those challenges, that forces like society to create new opportunities and new solutions. And that's where our technology comes in and starts solving for us.
yeah.
Uh,
I think, like you said, though, I think, the trade sector, the data center space, 10, 15 years ago, it wasn't seen as like a glamorous space, was it? It was, and like the trade as a whole, to young people is seen as, it's probably like you try and go into everything else before you go into trades. Like that's
yeah.
kind of like the
Yeah.
facility has always kind of worked in that way. Like, but ultimately, like now, I think that, like I said, I think the salaries and the
Yeah.
evolution of the space is making it an attractive, yeah, career choice for
Absolutely.
for young people.
I had this technician. He works on nothing but our generators, like installing them, prepping them, getting ready for them. And then me and the guys were talking on. He wasn't in the room. I was like, "How much do you think he clears?" And they were like, "Probably like 175." I was like, "Dang, like that is really really good." And he loves it. He gets a crank on engines. Like it feeds his like passion, and
Yeah,
he gets paid well. And so I think that absolutely, I think that they're becoming more and more, um, you uh, appetizing for like the young people to come in, right?
yeah. I think because I think like maybe 5, 10 years ago, obviously technology and going into being like software engineering, and that's
Yeah,
like where you
new
can.
thing.
But now, like, it's in terms of like compensation, at least it's almost on the level playing field, right? And
Yeah,
actually, in some ways, with AI, I obviously like software engineering is obviously keeps growing, etc. But with construction, like we're light years away from someone constructing a building or
yeah.
etc. Yeah, if that makes
Well,
sense.
well, when everybody's like wanting the software engineering jobs and like that, and because they paid a lot because there wasn't a lot of expertise in that. Like so, it was
Yeah,
hard to get a good software engineer to do coding and development and thereof. It's the same thing now with like that generator tech. There's not a lot of people that can do what that guy does.
yeah,
So like he can have a really high demand for his pay salary. And that's true. Like my MEP coordinator like can coordinate all the OFTI stuff. He can coordinate the commissioning. And he has those people skills too. And that's the construction job. And he's not coding, but it's his understanding there and he gets paid well too. But
yeah, yeah.
that's one guy on the site, and nobody on the site can do his job. So what's happening is that we're getting a little bit specialized in the construction space, and there's area there, and once you become specialized, then your compensation kind of goes up, and that's really
Yeah,
attractive. That's
yeah.
really attractive to people, you know?
Yeah, because it's like anything, isn't it? Supply and demand, right?
Hmm.
The more demand for something and the less supply, that you
Yeah,
can charge what you want, right? It's just like that. That's how it works. Some fortunately or unfortunately, depending on which side of the fence you're on. But yeah, like you said, obviously when people start specialising in things, that's when obviously your remuneration typically goes up, isn't it?
yeah. And on the software side, it's like, well, there's a lot of software engineers now. There's like
Yeah.
we've been educating a lot of software engineers, and so just because you can code in Python or code in Java or whatever, there's a lot of people that can do that now.
Yeah, yeah.
You know,
And I don't know whether I think there's always a balance because obviously we're seeing this now in trades and stuff. There's still a shortage in the trade
yeah,
space, right? And I
yeah,
don't think it's going to catch up as
no,
quickly as maybe software did because I think like
fast.
yeah, it's fast and I think obviously like it's harder for people at a certain age to then kind of retrain as a tradesman or trade person, etc. It's hard to go back into it because obviously it's physical, right? It's physical labor.
Yeah.
Yeah, which is challenging for people when they're getting older. So I think, and obviously there's a lot of people moving out of the industry. I think there's always statistics about like retirement, etc. and whatnot. So that obviously comes with its challenges because was like you said initially, there's still a massive labour shortage, isn't there?
Yeah. Yeah, I think,
Yeah,
well, I see people going out of retirement and back in. Like we've had that like a couple times where like they retired from like big pharma and then they're like, "Oh, well, we need an executive here to kind of lead us." And so they bring them back in. And they may not know the data center experience, but they have like that kind of like I don't know, those leadership skills, right? Because we have the shortage here in this industry because we're expanding so fast, you know, so much.
yeah. And yeah, well, it's obviously been a really interesting talk. I think we've covered a lot of points.
Yeah,
Been
we did.
fascinating. Obviously, talking to you over the past sort of 50 minutes or so.
We can
Yeah,
talk
so
forever, like just about one of those things for, you know, we
I
we had a
know.
lot.
I know. I think that's the thing. I said that to you when we discussed joining. I said like you literally could talk for hours, couldn't we? So, but I think you've got gave some really good insights into what obviously your own career and how it's evolved, but more importantly, where you feel like the industry is going. Obviously, there's a lot of great things in this industry. There's some issues, but I think the main thing is like you said, people are now working in partnerships in different areas to try and solve that.
Yeah.
And the number one thing I see more than anything is the time. Like everyone's trying to get the sites into production as quickly as possible.
Yeah,
Yeah,
you have people there now, like they'll buy some land, and they'll just want to create a data center. Like there's this idea, like, oh, it's close to this power, it's close to this fiber, and so they want to like all of a sudden and that's like an individual basis. And then so you have
yeah,
them, but they can't do it, right? They're like they're not a developer or they're not well versed. And so they're starting to partner up with like the bigger providers that said, "Hey, I have this site. Can you develop it for me?" And so you're starting to see like a lot, a lot more of that. Everybody's like kind of like trying to, get in the game a little bit here and there, whether or not it's like on an individual basis or if it's like as a company. So
yeah,
it's
yeah.
fascinating. But
Fascinating,
Sean, I
fascinating.
really enjoyed it. I really talked about it. You're a great person to talk to. This is fun.
Yeah, well, yeah. I obviously I'm not technical, but I love having these conversations. I feel like I learn a lot more about the industry and the challenges, etc. So
Yeah,
yeah, thanks so much for your time. I've really appreciated it.
absolutely. Anytime, man.
No problem.